If you have an object moving in a circle at a constant speed, even though the speed's the same, the direction is changing. And because the direction is changing, you have an acceleration. And we saw in chapter 3 that the direction of the acceleration points towards the center of the circle. Now in chapter 6, we're concerned with objects that move in a circle, but we're going to look specifically at the forces that cause that motion. So the ball is moving in a circle at a constant speed. There's an acceleration directed towards the center of the circle. Now we learned some things about forces in chapters 4 and 5. So if we know there's an acceleration directed towards the center of the circle, what can we say about the forces that act? We'll give you some choices. The acceleration is directed towards the center of the circle, and so therefore the net force has to be directed towards the center of the circle because of Newton's second law. And so when the ball is at the top of its motion, the acceleration is towards the center of the circle, which is down, and so therefore the net force is directed down as well. But now let's think about the individual physical forces that lead to that net force. So think about the ball moving in a circle again. We have a ball moving in a circle. If we look at the individual forces that are acting on an object, we can write down the individual forces and write a free body diagram. We're going to stop the motion at the same point as previously. We'll stop the motion when the ball is directly overhead. At that instant, we want you to draw a free body diagram. What does the free body diagram look like? We'll give you some choices. When the ball is spinning in a circle like this, there are two forces at work. One force is the tension force in the string. The other force is the weight force. And when the ball is straight overhead, the weight force is pulling down, and the tension force is pulling down as well. And so the choice is the one that has the weight force and the tension force pointing down. Together, they produce the net force that provides the acceleration of the ball towards the center of the circle.